if you're an engineer, you understand that if we were to turn on a spectrum analyzer here in the room or out in the street, we will see many different radio sources contributing broadcast, mobile. If we do it indoors, we're going to see a lot of Wi-Fi, digital cordless phone standards, and so forth. And we know from measurements now conducted in many, many countries, in many different situations, that the exposures from all these sources are roughly the same. So this is data that was presented at a World Health Organization workshop back in 2006, 2007, summarizing the situation at that time. If we would look at the data again, we'd see roughly the same situation today. So you see in this table, in the center, average base station exposures, and I've presented these as a percentage of the IGNIRP public limit to try and normalize the data, because the limits vary by frequency, as we know. And you see those levels are roughly the same for a base station, for broadcast TV services. They're roughly the same for Wi-Fi, unless you're measuring close to Wi-Fi access point. And again, if we measure close to some other sources, we see some slightly higher levels. But there's this great focus on measurements of base stations in particular, which is out of proportion to their contribution in the environment, because they're roughly the same as what we get from broadcast. We've had broadcast TV for about 50 years. We've had broadcast radio for 100 years. So why is there focus so much on base station signals, which are essentially just another branch of radio? The other thing we know from when we look at mobile networks, and this was data that we published a few years ago, 2012, after collecting measurements for 23 countries, we had about 180,000 measurement points for those countries, some of which had done measurements over many years, for example, the UK or Ireland or Spain or Greece, some of which we only got data for a handful of years or maybe just 1 year. That when we look at this from a technology point of view, while you do see some variation between countries because there's slightly different approaches to in the equipment that's used, the location at where you do the measurements, whether when you report the measurements, you report just the signal that is there at the time or you extrapolate it to the maximum. But broadly speaking, we see the same level in every country. And that's what we would expect for the mobile services, because they're using an international standard. Base station equipment is made by the same handful of equipment manufacturers, the devices similarly. And when I get off the plane in Warsaw and turn on my phone operates because it receives the same signal as when I turn on my phone in Melbourne, Australia. So we would expect to see the same levels. So when we've done so many measurements in one country, we can expect to see roughly the same levels in other countries. And those levels haven't changed very much over time. And this is from a report that was just published a couple of months ago in France by the French regulator. They have a program in place where they do quite a large number of annual measurements. And you see, if you look at the graph, the bar chart on the bottom left-hand side, that both the average level and the maximum level have not changed very much. And again, that's not a surprise from the engineering point of view, because we understand that as the mobile networks evolve, you first start out with a fewer number of higher powered sites because your objective is coverage. As the network grows, as there is more usage, your objective becomes capacity. And so you reduce the power of the individual sites, you put in additional sites that give you more capacity, but the overall signal level remains the same. And this is contrary to the perception in the public's mind that exposures are increasing with more base stations. And this is not the case according to the data that we're seeing when you consider the significant number of base stations. There have also been quite a number of countries which at various times have had continuous monitoring of RF exposure. Some of those systems continue today. Some of those systems have been closed. In the case of Italy, there was a national network from 2002 to 2006, In part, it was funded by some of the money from the 3G spectrum licenses. We got access to 50 million data points from that measurement network and did an analysis. About 40% of the measurements were below the detection level of the probes. So the sensitivity, that gives you an idea of how low the exposure levels are from the network. 50 million measurements, none exceeded the exposure limit. And in Italy, they have a more restrictive exposure limit than in the international recommendation. Very little variation, 18% from year to year. And the mean value, you can see the figure that's there. So looking at both this data and data that we've seen for multiple countries now, we've got this rough order that the mean exposure from base stations is around between 5,000 and 10,000 times below the exposure limits in the international guidelines. And we've seen a lot of data, millions of data points now to confirm that. So we had this report issued by a Spanish expert group in 2017, which said, given the fact that we've got all these measurements and we consistently see low levels of exposure, they said it's not recommended to continue to invest resources in new surveillance systems that do not provide significant innovation. So if we're not providing new information, if we're not showing something we don't already know, there's a question about the value of continuing the investment. And we've seen that in some countries where having had continuous monitoring systems or having had regular annual measurement surveys, that those have discontinued. So Portugal had a continuous monitoring system. They've stopped that. The UK used to do many hundreds of measurements a year. The last time I looked at the Ofcom, the regulator's site, they had done, I think, less than 10 measurements in last year. And in part, it reflects the lack of the reduced concern in the community. When we look about technologies, and particularly mobile technologies, when we compare them with broadcasting, so broadcasting signals are pretty constant. They don't vary very much over time because the nature of the technology. When we look at mobile services, they do vary because they move up and down in response to the amount of traffic that's on the cell. And so you see this variation over the course of a day if you were to monitor a base station over a 24-hour period. From a exposure limit point of view, from the ICNIRP guidelines, as we saw in Zenkovitz's talk, the limits are based on time averaged exposures, not instantaneous. And so when we look at it from a time average sense, we see that the exposures in base stations are even further below the exposure limit values. And this is data from a 4G cell, where you see that we see this reduction in the effective or actual power relative to the theoretical maximums. And we're starting to see regulatory authorities in some countries recognize this in how they assess compliance for base stations. So rather than doing this on a theoretical power that is never delivered in practice, to start to look at what the actual levels from the base stations are. And in turn, that means we get a more accurate assessment of exposure. As I mentioned this morning, when we look at the advanced antenna technologies, the beamforming associated with massive MIMO, we get a further complexity. One of the reasons why we're introducing this complexity is it allows greater capacity in the network. It allows greater efficiency in how we use the frequencies that are available and how we deliver the communication services, because there are objectives in terms of increasing the efficiency of 5G relative to 4G and so forth. But now we're moving to a situation where rather than having a constant beam pointing to a wide area, we're having beams that are switching in time in response to the traffic on the cell. And that means we need new techniques which are more statistically based in order to assess exposure. And in this new technical report that I mentioned in my answer earlier on, the IEC technical report or draft technical report 62269, they have looked at this in the context of massive MIMO, but it's not exclusively a massive MIMO issue. And you see that when you account for the influence of beamforming, the influence of traffic, people coming in and out of the cell, duration of calls, and so forth, you see that the real exposure from the base station is probably a factor of 6 dB or lower than the theoretical maximums. And as I said, we're starting to see discussion about this being introduced in regulatory compliance networks. In terms of what does the draft technical report recommend, it focuses on this idea of doing compliance based on actual maximum power, which is related to the actual traffic on the cell in a time average sense consistent with the limit values. And it can be used to establish compliance zone boundaries, which can be then monitored through software essentially built within the networks. It's often referred to in terms of counters and other features that can be used to assess compliance. One of the things that's maybe not fully understood by those who aren't directly involved in this standardization committee is this approach potentially can be applied not just to massive MIMO, but it can apply to any existing technology using fixed beams as well. So we can use it with 4G today, we could use it with 3G in theory. And in essence, the idea is that you will establish an actual maximum based on the time averaged approach. You would use that as the basis for assessing compliance. And then from a network monitoring point of view, you make sure that the base station cannot exceed that average. And if for some reason the base station configuration changes, for example, if you wanted to introduce additional carriers or change the transmitter powers, you would go through this exercise again and reevaluate the compliance boundary. But this is really about assessing real and getting a more accurate picture of exposure rather than theoretical maximums, which a lot of compliance is based on to date. I won't go through the details of this spreadsheet or this flowchart. You'll see it when you get the presentation afterwards. Just where are we at in the process of developing this? So I mentioned this standard previously, 62232. This is the one that has the basic technical method for how you can assess massive MIMO antennas or other base stations. That was published in 2017. This technical report is the series of case studies showing how to apply the 2017 standard to a range of different situations. It's going through approval process, expected to be finalized. I think the voting will end around January, February next year. So by about the middle of next year, it will be published. That will then feed into the update of the 62232 standard. One of the things I should have mentioned probably in my remarks on this standard earlier was that there is close cooperation between IEC and ITU in this area. And there are references and cross-references in the ITU standards for base station compliance assessments, such as K100 and the 62232 standard. So if you're applying those techniques, they're technically equivalent between the different organizations. And this is a really important opportunity for harmonization of compliance assessment approaches. I mentioned in my earlier presentation, the European Electronic Communications Code talks about having a harmonized approach to electromagnetic field for deployment of small area wireless access points and other technologies. And this standard is adopted as a CENELEC standard in Europe. What do we know about 5G at the moment? So there's been very little data published so far. The only one that I have seen in the open literature is from conference presentations from Telstra in Australia, where they have a small 5G test network in Queensland, and they've done measurements both indoors and outdoors, and they've presented at a number of conferences the results of the measurements so far. And you see, if you look at it here, what they've done is, in an outdoor situation, compared the results of the measurements in different frequency bands, and then at this end, what they saw for the 5G network. And the 5G exposures were about the same as what we see for the other pre-existing mobile and other technologies. So in answer to the question, what do we expect for 5G? We expect it to be broadly the same as what we get today. No major changes. As I'm coming to the conclusion, one of the things I thought that I would just bring to your attention is the topic of everyday exposures that people in the community experience. And as with many things, it's helpful to look at reviews rather than singular studies in terms of getting an overall picture of a situation. So this was a systematic review published in 2017, 21 studies, range of different countries, European and non-European, some differences in the methods used to collect the information, but essentially they were about measuring exposures for people in their homes, in public transport, as they went about their everyday activities. And this could be, in many situations, was done with a monitoring device carried by the person. Overall, they found, as we would expect, the levels are much below the limit values. In some of the countries, the highest levels were in public transportation, not from the network infrastructure, but from the use of mobile phones sitting beside somebody on the train, for example. In outdoor environment in general, the main source was mobile services, but they assessed that because of the equipment used, the contribution from broadcasting was probably underestimated in quite a number of the studies. And the exposure levels in homes was generally lower than outdoors, essentially because we lose some signal through attenuation from the building. If we look at it from a pictorial sense, if we look at the right-hand side first, so this is outdoor spot measurements. So this is, I guess, I chose this one because this is a little bit like the survey work that is done sometimes about measurements near base stations. So you see in the outdoor environment, the main contribution is the downlink from the base station, and that's probably in many cases because they're also measuring close to the base station. Then there's broadcasting, and then there's other services. And this is true across quite a number of countries. If we look on the left-hand side, in the home environment, well, first off, you can see that the exposure levels are about half what we get outside. But in the home environment, we've also got significant contributions from DECT, digital cordless phones, and from wireless LAN Wi-Fi situations. We spend far more of our time indoors than we do outdoors. People go around continuing to measure lots of outdoor base station measurements, but if we're talking about population exposures, then it's actually contributions from other sources that often aren't measured, which are significant and would need to be factored into any sort of health-related study. So just some quick conclusions. Multiple measurements over many years in many countries show that the exposure levels for mobile communications networks is very low and is staying low despite the continued deployment. In the outdoor environment, mostly we need to look at the downlink from the base station and the broadcasting. Indoors, we have other contributions to sources that may be significant. Because we've had this vast accumulation of data, we can say quite clearly that post-installation measurements are not needed for the vast majority of sites. We know they're compliant. Indeed, in K100 and in IEC 62232, there are simplified assessment criteria which say, looking at the EIRP and essentially the mounting height of the antenna, we can know that the antenna is compliant without doing any measurement or calculation. And these approaches have already been adopted in Latin America, in Colombia, in Brazil, as part of their regulatory frameworks. As we move into the future, and particularly with massive MIMO, these statistical type approaches are becoming more important to get accurate time average assessments of exposure. And any country that's looking to update its regulatory framework should be looking at this now. And that's it for me. Thank you.